Okay, so for this one, I'm going to show you some big process you're going to have to do to integrate a lot of things, and it's called U-Substitution. If you look at this function for the first time, what is your first instinct going to be? You're going to want to multiply this out and then take the integral of each term, just like you did for derivatives. That's not very hard. But what if it said squared right here? So it was 10x times 5x squared plus 1 squared. This kind of looks like a chain rule problem that we did before. Remember with derivatives, you would take the derivative of everything in respect to this and then take the derivative of the inside thing. You guys remember that? That was chain rule. Well, when you're doing integrals, there's actually kind of a reverse chain rule. This would be the first real thing you would check to do. In a later unit, I believe it's 2 units from now, and it's called Advanced Integration Techniques. We're going to talk more about this integration by parts and other really complicated things that you're going to need to do to integrate things. This is the easy thing. This is the first thing you want to check to see if you can do, and that is U-substitution, because what's the word I'm looking for? It's not very difficult. So after just simple, if it was just like 10x, then obviously you would just do x squared, it'd be 5x squared. But because there's all this stuff, it's a little more complicated than that. So we're going to figure out how to do this. So the first thing we have to do is we have to define what U is. Now U will generally be what is the inside thing. And I think you'll understand what U is once you see the rest of the problem. Because basically what we're doing is we're going to find a U, and then we're going to find a du, or like the derivative of U, which is actually going to be du dx. But you'll see in a second we're going to multiply this dx over. Well, I'll leave it like this for right now. So you need to find a U in here, and you need to find a du dx. So what part of this is the derivative of another part of this? Well, 5x squared plus 1, the derivative of that is 10x. You see that? The derivative of 5x squared plus 1 is 10x. That's a little suspicious, and you should already think, I'll just do U-substitution. So U would equal to 5x squared plus 1. Du would be the derivative of this, which would be 10x, right? However, because we want to make this work, you'll see why in a second. We're actually going to multiply this dx over, so it'll be du equals 10x dx. Looks like that. And then what we're going to do is look at this, and we're going to substitute things in. The reason we keep this dx over here is because there's a dx in the original integral, and we want to substitute it. So what we're going to do is, this is the u part, and now we're doing the substituting part. 5x squared plus 1 equals u. So we're going to put in u squared, because this thing is being squared in the problem. And then du equals 10x dx. So 10x dx, it's all being multiplied together, so I can just say it's u squared times du. So you didn't know how to take the antiderivative of this, but you know how to take the antiderivative of this. This equals u cubed times the inverse of this would be 1/3 u cubed plus c, of course. And then you can't leave your answer like that because there's no u's in the original problem, so you then just have to substitute back in what you made u. So the answer to this problem would be 1/3 5x squared plus 1 cubed plus c. So it's a technique that you're going to have to be using a lot, but you'll get tons and tons of practice by your teacher, and it shouldn't be very complicated to figure this out.